Hey again, and welcome you to the industrial hydraulics. Today's topic would be very important because today we will be covering the hydraulic components, the diagrams, right? So whenever we study a hydraulic chart or we go on study a equipment, we need to understand what are the components involved. Let me show you an example of it. For example, if I show you something like this, can you understand as to what is drawing is and what are all components in this is a basic diagram and we will study all of this in this class. See, if we come across and there are thousands of hydraulic components, means with little type of tweaks, little type of changes, and we need not understand all of these. We just need to understand the basic ones which I have covered here. Then when we will go on studying the different charts, or when we will go to study different equipment, then we will know that why are these used. So with time accordingly we will understand all of this, but for now we will just go on to move with some basic components. So first is this fixed displacement pump. In hydraulics symbol, whenever we come across this type of symbol, you understand that if this is filled one, it is generally hydraulic. Okay, whenever you come with a blank one, this is not filled and it is a pneumatic one, you must remember. So first, whenever we come here with a circle and a filled one here, you know that it is a hydraulic one, and this is the image of fixed displacement pump. But the opposite one, see, the direction here is outside. Okay, the arrow is moving outside, so this is a pump. But in the hydraulic motor, it is moving inside arrow. There is little changes between the pump and the motor. This is the generally one change. In pump, the hydraulic fluid is going with a high pressure or with a high flow generally in the outside direction. In a motor, it is reverse. Okay, so hydraulic motor, this is the hydraulic motor. When we come to electric motor, this is the electric motor symbol. This is generally designated by around a circle and M. Whenever it comes to a square and M, remember that this is not an electric motor, it is a motor but powered by some other source, not hydraulic, not electric. Next component is single acting cylinder. See, if whenever you see a cylinder, you have to see the inputs. There is one input here. There are two inputs here. Okay, the in line or the connection lines. So whenever we see there is one line, it will be a single acting. You don't need to remember anything. This is very simple one. Single acting cylinder means it will go here. There is some load, and whenever there is a increase in pressure, the piston will move upwards, the load will shift this side, and automatically the load will also come down. Okay, whenever the pressure is removed, we will understand this. Don't take stress here. Now this is a double acting cylinder. Here what happens is, suppose this is the inline. Okay, so here is also fluid. Whenever the pressure in this line increases, the pump will move. Suppose the piston moves here. Okay, and the fluid here comes out from this direction. Okay, so pressure increases. Let me show you. So this is the pressure increases in this cabin. So the piston generally it comes here, then here, then here. Okay, and all the fluid moves out. Again, what happens? So now the new location, new position of this is, we can say like this. It will look like this. Okay, so this one. Now the pressure will be in from this side, means the pump will act from this side and the pressure will build in this side. So here it will be pressure of high pressure, here low pressure, so the piston will move in this direction. Here we can see that the piston moved in this direction, here in opposite direction. This is how the double acting cylinder works. Okay, now let me remove this. Now here is an electric motor. This is also a electric motor. If some image comes, then you can. So it will be written by M, or if not M, then there will be a direction provided here. Okay. Now this is a filter. Remember that this is the filter. Filter generally when we will study in the diagram, here is the tank or sump we can say. Then a filter or strainer is there, and from here only the pump is used to pumping the for pumping the hydraulic fluid. What is the work of the function? The function of the filter, it is generally used to remove the contaminated material or the particulate material that are present. Now, in any hydraulic circuit, you will see one straight line and some dotted line. What are these dotted line? The dotted lines are the pitot line and the straight line are the piping. Pitot line you can say generally is a secondary line, okay, or a superficial, not superficial but a secondary line which is used. We will come across this. Now there are spools. What are these spools used for? Spools are used to change the direction or to connect and disconnect the pumps. Okay, so there we can see, you can see that spools will be used. Generally, this is a this is a symbol. So it is a three directional. So you here there are three directions. You can also find two for second means dual ones. So this is also a spool. Here we have read the direction of rotation, that is the electric motor. So these are the directions. Next, in the spools you will also find some arrows. These are also the directions. Okay, these are also the directions. Remember that the arrows show directions. Pressure line, pivot line we have studied. Check valve. Check valve is used to control the flow in one direction. See, whenever this is my check valve, okay, I have used it. Whenever the flow, whenever the hydraulic fluid comes from this direction, it goes easily without any restriction. But whenever it comes from this direction, it is being restricted and it cannot flow in opposite direction. So whenever we need a single directional flow, especially after the pumps, we don't want the pump to get overloaded, right? So this is my pump, and after it what we will do that we will use one check valve here. So the flow will go in this direction and not in opposite direction. When if for example if we don't use it in this component, and we have chances that the flow might return back, so here the pump will be damaged. Therefore in such cases we use the feed check valve. Now here is a shut-off valve. The function of the shut-off valve is to disconnect the lines. Okay, for example, here is one circuit and here is one circuit. I want to disconnect them, so I am using a shut-off valve here. Union, whenever you see some dots or some joints, these are, you can say generally joints of the piping system or joint of the hydraulic circuits. These are termed as union. Next, we have cross. What are these cross? Crosses are generally used when there are overlapping circuits. For example, this. But you can't do here like this because it will be a union. Remember, a small dot here will change the representation of the circuit. So cross means whenever zigzag means a pump, a circuit line is coming there, and we don't have image, means we don't have any place to show this. So what we do is we will put a circuit line cross here, and most of the time we will use it. Okay, it is very useful because it terms that it is overlapping circuit and they are not the same pipelines. They are different pipelines, they have different hydraulic fluids, right? If not hydraulic fluids, then they are different lines, we can say. Okay, now next we will move on to the operations. See, these are used for operating. Okay, we have push knobs, we have pull push knobs. Remember, this is push knob and this is pull. It is used for pushing, it is used for pushing and pulling both. These are lever, and there are also pedals. Okay, there are also pedals. And then this is single solenoid. Solenoid, what is the solenoid? This is electrical operated system, right? So whenever we will see the diagram, then we will study. And here also we have spring regulated. Whenever you find a zigzag line like this, you understand that it is a spring. Next we have accumulator. Accumulator are used to means reserve some of the hydraulic fluid, to store some of the hydraulic fluid, hydraulic pressure definitely. Why are these accumulators used? See, whenever you go into a very big equipment, the chances that there may be some failure, or to compensate the pressure. Okay, to compensate the pressure, generally we use accumulator. So it stores a storage. For example, you have some this is your house. Okay, this is on the top floor. You have a what we say it, we say it water tank. Okay, water tank. It reserves the water, like, right. So you don't have to always consume the groundwater. It stores it. Whenever there is empty, you will go and fill it. So this is the same storage of the accumulator. It will store it, and whenever it faces there is some pressure drop due to some other failure or some leakages, then accumulator fluid is used. Next, we have gauge. This is a pressure gauge. Okay, to symbolize the gauge, we generally use this type of symbol. This is a gauge one. Next, relief and pressure reducing. Remember that the function of this, we will cover the differences in the next video, right? The function, we will also cover the working of this in the next video. Working and the difference. Relief valve is used whenever in a line the pressure increases from a fixed value. Means suppose that I have set a pressure of 150, let us make it small, 1 bar. Okay, very less pressure. I have set a pressure here 1 bar, and my hydraulic fluid pressure is 0.8. It's okay, there is no tension, there is nothing. But what happens if my designed pressure is 1 bar and I provide 1.2 bar or 1.1 bar? A little increase in hydraulic pressure tends to possess a very greater risk, right? So it may damage the components, it may lead to, and you know that whenever in hydraulic circuits there is a little, what we can say, a damage or little, then it can be a very fatal incident. So to prevent this increase, generally we provide a relief valve, pressure relief valve, also in short form we say it as PRV. Okay, pressure relief valve. So what is the function of the pressure relief valve? Whenever the pressure increases more than 1 bar, it will operate and the excess pressure will be released out. So the component is safe. This is generally a safety device, we can say. Okay, so pressure relief valve is a safety device. Next, what is the work of the pressure reducing valve? See, whenever we come over the pressure reducing valve, its work is to provide a limited pressure to the actuator, to the cylinder. Here there will be cylinder and its requirement is suppose 2 bar. The pressure here is 3 bar. So what we will do? The pressure is 3 bar. Whenever the pressure comes here, it will remove the excess pressure out and provide the supplied pressure to the cylinder. The function, the working, we will look in the next video. Okay, so this is the function of the pressure reducing valve. Remember that pressure relief valve is used to remove excess pressure, and this removed fluid will go to the tank. Okay, and here in case of pressure reducing valve, it is connected directly to the actuator. The required pressure is only sent. The excess pressure is released, the required pressure is sent. This is the difference you need to understand for now. Next, we will understand in details in the next video. Now see, this we have studied the proportional valves, right? This is a two-way, two position. See, two-way, why? And two position. Here we have two positions, right? Here we have two positions. This is position 1, this is position 2. Similarly, here is also two position, 1, 2, 1, 2. Okay, two-way. This is the single way, this is the blocked way. Okay, there are two ways now. Here there is three-way. See, in this direction, in blocked direction, in the third direction. Here this is four-way. How many ways? 1, 2, 3, 4. Okay, these are four directions in which the fluid can flow. This is whenever there are blockages, we will consider it is only one. Okay, we will not consider it two. But whenever there are this type of systems, these are all different, right? Next, we have completed the basic things. Now let us understand what this circuit is. Okay, you also remember them and speak them with me. See, this is the starting tank. We will start from the basic. This is the tank. The tank line is connected to a motor, right? This is a motor. We were going through this circuit, right? When the motor turns on, it spins. Whenever it turns on, it operates the pump. This is the pump. Which type of pump? This is the hydraulic pump, because we know from this that it is a hydraulic pump. It is closed one. It is filled triangle, right? So the pump pumps the fluid here, and here we find that this is a union or a joint, you can say. This is a union. Now see, the water is flowing, the hydraulic is flowing, and we have a pipeline here. This is a proportional valve. Okay, what is the, or we can say it is a direction control valve because its function is to control the direction. So this is the movement of the fluid. The proportional valve is open and it is going through, and now here it is creating a high pressure zone. A high pressure zone is created. The piston will actuate. Okay, finally the piston will come to some this position. Okay, so the piston will come to some this position, and here all the hydraulic fluid is now filled here. There is high pressure. Now all of the rest fluid what is there, whenever the piston is trying to come here, here is also fluid. Okay, in the back side, the back side fluid are moving from this out and going to the tank. Okay, now what I will do, see, this is the first case. Now just I will duplicate this slide, 1 minute. Achha, now I have duplicated it. Now see, what I will do, I know that the position, current position is this one. Okay, and this is all empty, right? Here is some hydraulic fluid and here is no piston now. What I will do is I will just move this hydraulic fluid, as you may say, that I will move this component. Now before moving this component, let me say you that this is spring operated, this is spring, and here it is also solenoid operated, so electrically operated. Okay, some solenoid is just like a motor, it moves the proportional valve. So I am operating this spring and I am operating the solenoid. Ting, 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 and it comes here. For example, now it comes here. Where will the fluid go? Tell me. See, the thing here is that it is blocked, it is blocked, it is blocked, it is blocked. Okay, the pump will provide the pressure, but since these all lines are not connected, there will be no movement. All lines are disconnected and the piston will remain in this position. If there are no leakages, remember that if there are no leakages, then piston will continuously remain in this position, in the loaded position. Fine. Now what I will do is I will just move the solenoid a little bit more. Sorry, the DC valve a little bit more. Okay. Now I have moved the DC valve to this position. What will happen? See, now again the pump is pumping the hydraulic fluid. It will go through this circuit. Then the route changes. It moves straight in this, but now this will move in this direction. And it will create a high pressure in this zone. As soon as it creates a high pressure in this zone, there is a low pressure built in this zone, and it is controlled tank line. The excess fluid will come out to the tank line, it will return to the tank line, and this is the excess fluid. It is it is returning to the tank line through this circuit, and this will generally push the piston in this direction. Then again we will see that the piston will come to this direction. Again what will happen, that again our solenoid will move the solenoid will move the direction control valve in this direction. Again there will be high pressure generated. So this continues, the system continues like this. So who is the main, whose role is the main? We can say the DC valve, which is providing the direction here. Okay, its role is main, most important. Now we have understood all this. Now there is some circuit here in the left side. Let me just move this solenoid to the center. See, now my the DC valve, the proportional valve is in the center. Now my pump is providing the pressure. Remember that this is in fixed position here. Why? Because it is blocked. There is no change in pressure. But what happens? The pump is providing the flow. Where is the fluid going? Will it not damage the circuit? because it is blocked now. The hydraulic fluid is unable to uh, go to this zone, and there is no circulation here. There will be increased pressure. For example, if my pump is providing here, let us suppose that there is a pressure fixed of 1 bar, and here there is an increase in pressure due to resistance. Okay, so whenever it exceeds 1.5 bar, you know that this is used to save the circuit. We need to save it, because else what will happen, the pump will keep on providing the flow, resistance will be provided, there will be increase in pressure, and there will be a damage in the component. So what will happen is that now this will go here. 1 bar is set. So see here, it is disconnected, there is no connection here. The water will not be able to, the fluid will not be able to move in this direction. So it will try to move in this pilot line. Whenever it tends to move in the pilot line, for example here my pressure is 1.1, due to some resistance it has exceeded, it will push the valve. Okay, so now the valve will be pushed here and will connect directly. Remember, now what will happen, it creates a low resistance path and the fluid will flow through this to the tank. Okay, the excess pressure. Now what happens is that the pressure has now become normal, and I have connected the DC line here. See, I am 1 minute, I have now connected the DC valve directly. Okay, so the pressure inside the circuit is reduced. Now what will happen? So for example, now my pressure is 0.9 bar. So this pilot line will not be operated. This is 0.9 and my restricted pressure is 1 bar. Only after 1 bar the pilot line will operate the pump. But since it is reduced, there is no function. The fluid will move through the pilot line. There is no I will not deny it, but what will happen, that the spring pressure is greater than the pilot line pressure, so it will again push the arrow to this side. So initially the arrow was here when the pressure was high, but again it will push it to the original position and the route will be blocked. So here the fluid will not move and it will move to the tank again. This was the function of the pressure relief valve, or the PRV. Remember, and we will go into more detail I will move it with a much larger image in the next video. Till then, just keep on revising the circuit, just keep on revising the diagrams. We will meet again with some new episode with the differences of the pressure reducing valve, the pressure relief valve, and the limiting pressure valve. Okay, till then, tata, thank you, bye bye. And if you do like our video, liked what we taught, what you learned, there is something new, then please do like us and share the channel. Thank you.